The first video in this section didn't play. Fortunately, the textbook check didn't ask any questions on the first video, so you guys were in the clear. But I put a new video in, and I'm guessing nobody knew that, and it's only like a little over 4 minutes. So I thought we would start off by just playing that video, and everybody can watch it, because I think it does a good job of explaining the law of detachment and the law of syllogism, which are two of the 3 laws that we learn in this section. So I'm going to play it and turn up my volume.
Reasoning. We're going to look at some given conditional statements to make facts or conclusion. We're specifically going to look at the law of detachment and the law of syllogism. We're going to start with the law of detachment. It says that we need to identify the hypothesis. If another statement has the same hypothesis, then you can make a conclusion. Let's look at a given statement, because then this will make a lot more sense. Let's say that we're given the statement, if there is lightning, then it is not safe to be outside. Well, then we're told that Preston is outside playing baseball, and then he looks up and he sees some thunder and lightning. Well, we could say, Preston sees lightning from the baseball field. And see, it's not an exact match to our original conditional statement, but it's the same idea. The hypotheses are the same. If there is lightning, Preston sees lightning. Well, then we can make the same conclusion. It is not safe for Preston to be outside. Now, let's take a look at the same conditional statement. If there is lightning, then it is not safe to be outside. But this time, we're going to do a restatement of the conclusion rather than the hypothesis. It's not safe for Preston to be outside. Well, you know what? There could be a lot of reasons why it's not safe for Preston to be outside. Well, what if there are lions roaming around? Definitely not safe to be outside. Or what if there's a big, huge windstorm? Whoa, definitely not safe. Well, what if there are little green alien men running around all over the place? Definitely not safe to be outside. Well, again, there could be a million reasons why it's not safe to be outside. We just cannot make a conclusion when there's a restatement of the conclusion. So, to summarize, the law of detachment says that we need to identify the hypothesis. If another statement has the same hypothesis, we can make a conclusion. Putting it into our symbolic notation, if P, then Q is true, and P is true, and again, P is just a restatement of the hypothesis. It doesn't have to be word for word verbatim. Well, then Q is true. Well, now let's look at the law of syllogism. And it says you can make a conclusion if the hypothesis and conclusion from 2 conditional statements are the same. Let's look at an example, make a lot more sense. Let's say we're given a statement. If everyone does their geometry homework, then they will pass geometry. If everyone passes geometry, then Mrs. Gray will have a party. Well, we can conclude then that if everyone does their geometry homework, well then, voila, Mrs. Gray is going to have a party with lots and lots of cake. Well, let's look again at our original statements. There is a match. We have a hypothesis that then we will pass geometry, and another match if everyone passes geometry. Well, we basically have just crossed those out and combined our hypothesis that we started with and our conclusion that we ended with. We just crossed out the matches and combined what's left over. If everyone does their geometry homework, then Mrs. Gray will have a party. So to summarize, the law of syllogism says you can make a conclusion if a hypothesis and conclusion from two conditional statements are the same. And that's again where we saw that match. And putting it into our symbolic notation, if P then Q, if Q then R, well then we can conclude then, if P then R. Again,
cut off the very end, but you get the idea. Okay, so law of detachment is pretty easy. Let me escape out of this. Sorry. And it just says, if you're given any conditional statement, and then you're told the hypothesis happens, you can conclude the conclusion happens. You know, if I use the one from the other day when I said, if it rains, then I will bring an umbrella. If that's the statement, and then I said, John just came in and told me it rained, or it's raining, I could conclude, I will bring an umbrella. Okay, so that one's pretty easy. It's just identify the hypothesis, identify the conclusion. If you're given the hypothesis to be true, you can then assume the conclusion is true. Okay, law of detachment. That's what that one is. Law of syllogism, you guys remember the transitive property? If x equals y and y equals z, then x equals z. Right? If x equals y, y equals z, if these two are the same, then you can conclude those two are true. It's the same thing with sentences. Okay, you have to be really careful here, though. You have to identify the hypothesis and the conclusion of the first statement, and the hypothesis and conclusion of the second. The conclusion of the first must match up with the hypothesis of the second for those to cancel out. Then you can say the hypothesis of the first equals the conclusion of the second. So the law of syllogism, you'll always be given two sentences, two conditional statements. Okay, one's an if-then, the other's an if-then. And then as long as the conclusion of the first is the same as the hypothesis of the second and they cancel, then you can conclude that if the first thing happens of the first conditional, the conclusion of the second will happen. That makes sense? Okay, so on that one, the hint that you're going to be able to say, it could be the law of syllogism, is if they give you two conditional statements. But just because they give you two conditional statements doesn't mean you can conclude anything unless those two match up in the middle. Let's see. If it rains, then I will bring an umbrella. If I bring an umbrella, I will have a great day. If it rains, I will have a great day. Because the conclusion of the first statement matched up with the hypothesis of the second. Okay? If it rains, then I will bring an umbrella. If I have a great day, I will bring an umbrella. Can't really conclude anything because I will bring an umbrella was not the hypothesis of the second conditional statement. So I don't use a law of syllogism in that example, even though there were two conditional statements presented. Make sense? Okay, the third law in this section is something called the law of contrapositive. And the law of contrapositive says, if you're given P then Q, a conditional statement, if P, then if hypothesis, then a conclusion, and then it says the conclusion doesn't happen, it's the not, the inverse of that conclusion, then you can conclude not P. Okay? If we assume if the temperature drops below 32 degrees, then it's possible it will snow. If that's my conditional. And then I tell you it's not snowing. From that statement, even though it may not make sense, you're going to be able to say it's not below 32 degrees. If they give you not P, you can conclude, or not Q, you can conclude not P.
Dismiss the high school volleyball team for their game. Good luck, girls. Also, if you are in Mrs. Sewell's interventions class, you need to go to Mrs. Ferguson's room to pick up your donut if you haven't already done it. Thank you.
I should go. Okay, so let's look at a couple of these examples for the law of contrapositive. Babies wear diapers. So how can I make that a conditional statement? Babies wear diapers. How can I make that an if-then? Because I can make any statement conditional.
If it's a baby, they wear.
Yeah, if it's a baby, then they wear diapers. So there's my conditional. Okay? What they say here is my little brother does not wear diapers. So my little brother's not a baby. That's how you use the law of contrapositive. You assume that conditional statement is true, then they give you not the conclusion, you assume not the hypothesis, or the inverse of the hypothesis. Determine the conclusion from this statement. If you are not in Chicago, then you can't be on the L. The L is just their subway. If you are not in Chicago, then you can't be on the L. Then they tell you Bill is in Chicago. What did they give us? Did they give us not P or not Q? If you are not in Chicago, so P is you are not in Chicago, then you are not on the L. Q is you are not on the L. They give us not P. The law of contrapositive, you have to be given not Q. So if they give you not P, you can't conclude anything. You can only conclude something. So if they said you are on the L, I can say you are in Chicago. But if they say Bill is in Chicago, it doesn't work. That's not the law of contrapositive. So you have to be really careful and realize the law of contrapositive only works if they give you the opposite of the conclusion, or Q, not the opposite of the hypothesis. Okay? So law of detachment, law of syllogism, law of contrapositive. Okay? They're explained well in the section. So if you're confused still, go back and reread. Never hurts to reread now that you had a little introduction to it. Just realize it's so much easier maybe to make sense of it if you put it in terms of P and Q. Law of detachment just says P then Q. You're given P, then you can conclude Q. Law of syllogism, you're going to have two conditional statements. If P then Q, and if Q then R. And you have to make sure that the conclusion of the first matches with the hypothesis of the second. So they cancel out. Then you can conclude if P then R. So you're going to have two conditionals with the law of syllogism. The law of contrapositive, you're going to be given a conditional. They're going to give you the opposite of the conclusion, and then you can conclude the opposite of the hypothesis is true. Law of contrapositive. And remember what contrapositive is? You switch P and Q and make them both negative. So that's contrapositive. Okay, the last piece in this section is something called truth tables. And truth tables are just a way of for you to organize conditional statements. And in order to put a truth table together, there's a couple of things you need to know. The symbol of an upside down V is and. The way I always remember it is I can make an A out of it. And. Okay, the symbol of a V is or. Okay, and this symbol, remember, is not. Okay, so far so good. So if we do a really simple two variable truth table, I'm going to assign, there are four possibilities. I could have both statements true. I could have P true, Q false. I could have P false, Q true. And I could have P false and Q false. Okay? When you make a truth table with two variables, you always need to write it with the first column in this exact order.
So if it was continued, would it be TTFF, TTFF?
Well, it won't be continued. Those are the only combinations you could have with two variables. One could be true, the other could be true. One could be true, the other could be false. One could be false, the other could be true. They both could be false.
So every time you're like P and Q and like all that stuff.
Yep, that's what it needs to show.
Then gets bigger.
What's that?
So like when you P and Q variables, when there's more of them, did your truths become?
Yeah, you have more possibilities, so you're going to have a longer table the more variables you go out. In the textbook, when we get to the truth tables, maybe. Law of syllogism. I'm just showing you for reference so you can go back and look. So there is just the P and Q, and see how they always go true, true, false, false for the first column. That's always the way it'll be. You don't get to make up your own order in a truth table. The first column is always going to be true, true, false, false, if there's just 2 letters. Okay? Then notice when they get into 3 letters, this is the first 2 columns. Actually, all of them. You're going to go 4 trues, 4 falses. Then you go 2 trues, 2 false, 2 trues, 2 falses, and then you go true, false, true, false, true, false, true, false. That will make sure you get all the combinations those 3 variables could have with each other. And that's always the order it will go in. You always do that. 4, 2, 1. Everybody see that pattern? Okay, we won't go beyond 3 on a test or quiz. The most you'll see is 3. So just remember that pattern. Okay, and if you want to review it, you know where it is now in the textbook. Okay, so let's just talk about the pattern of 2. If I want P and Q, and I want to know what the truth value, is that true or false? I'm trying to think of how this will work. If I have 2 statements, one statement is when the hour hand is on 3 and the minute hand's on noon, it's 3 o'clock. Is that true? Okay, so that statement would have a truth value of true. Then I say, with the same clock example, when the hour hand is on 2 and the minute hand is on 12, it's 12 o'clock. That's a false statement. So my first statement would have a truth value of true. My second statement would have a truth value of false. So that combination would be right here, that second row. Okay? If I'm going to decide if P and Q is true or false, this is what has to happen. They both have to be true for P and Q to be true. If I said, when the hour hand's on 3, the minute hand's on noon, it's 3 o'clock, and when the hour hand's on 2 and the minute hand's on 12, and it's noon, that whole thing is false because one thing is false. It's an and statement, so they both have to be true for the truth value to be true. Is that clear? So the only way this statement is true is right here, when the first and the second are true. If you don't have the first and second true, every other case, the truth value is false because it's an and. They both have to be true. Okay? If I'm going to ask P or Q, well, if I said the first case, which was true, or the second is true, it works. It's still true because one or the other has to be true for that to be true. So the or statement, either one can be true and the whole statement's true. So the only time the or statement is false is when they're both false. So this is false here, but it's true here, it's true here, and it's true here because it's an or, one or the other. So the and is only true when they're both true. The or is only false when they're both false. Okay? And how these work, let's say I'm going to go a little further and I'm going to say not P and Q. Well, to do this one, I need to have a not P column so I can compare them. So I'm going to do this not P column first and then go look at this one. So not P just means the opposite of P, right? So I look at the not P column and it's going to be false, false, true, true. It's just the opposite of the P column. It's the opposite, not. Now, if I'm going to compare not P and Q, I'm going to look at both of these. Not P is F, Q is true. It's an and, which means that's a false statement because they're both not true. So that's false. Look at this one. This one's false. This one's false. They're false. This one's true. This one's false. It's false. True, false. false. No time could not P and Q be true. Okay, so you just gradually kind of build these tables, eventually getting to maybe the column that we're really trying to figure out. Do you want me to do a 3-column one? PQR, or are you guys understanding it?
Can you do PQ, P, Q, not Q, and not Q? If not Q, then P. What? Not Q.
True, false. Okay, not Q. So not Q will be false, true, false, true.
And then not, if not Q, then P.
That?
Yeah.
So is it an and or an or? Is this a, that doesn't sound like a truth table. It sounds like maybe a law of detachment problem. I don't know. Is this a,
It says create a truth table for the logical statement.
Is this in Big Ideas?
Yeah.
let me look here. If not Q, then I would say it's an and. So not Q then P would be, I'd look at not Q and P. That one's false because they both have to be true for it to be true. The second one would be true. The third one would be false, and the last one will be false. The only time it's true is if both of them are true.
Oh, so Q and
Not
P
not
and
Q,
not Q
have to both be true
Okay.
for the and to be true. Check
Awesome.
it and make sure. So I'm not, so I'm not leading you astray. Okay. Are they saying,
If these,
must
if
be
they're
an-
both true, or this and this one are true,
okay, so if they're both true,
but this one's
this is true, this is false, this is true, this is true, this is false, this is false. So I'm thinking it must have been an or. If not Q, then P is an or statement.
Yeah.
Because the or statement's only going to be false when they're both false.
oh okay. An or statement is
Mhm.
only going to be false
When they're both false. Because one has to be true or the other.
Okay.
Okay. I'm going to do just a PQR one real quick. I don't remember if there's one on Big Ideas, but there may be one on a quiz. I want everybody to try this one. Maybe I'll just call. What will my first column look like, Cole?
True, true, false, false.
With 3 letters,
Wait.
what's the, that's okay.
It would be true, 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 true.
Okay.
False, false, false.
Good. Don't go too far. Okay. Let's go. Caleb, give me the second column.
True, false.
No,
Okay.
go to 2. This one was 4 trues. The next one's going to alternate with 2s.
Okay, so true, true, false, false, true.
Yep. Raven, third column.
So you need to just go over the one.
True, false, true, false, true, false. Good. Okay. So what I'm going to give you ultimately at the end is what I want you to find is not P or Q and R. That's going to be the last column. You're going to have several in between. I don't know. I'm just making it up, so it's going to be similar probably. So just to get you started, what do I need that I don't have that will help me with this? The not P. So go ahead and make another column with not P. And how would I fill in that column? Aiden?
4 falses, 4 truths.
Yeah, do you see the 4 truths here? And if it's not P, it's going to be the opposite. What else do I need? Well, I think I need Q and R. So Aiden, we'll try this one now. Q and R. So what's the first entry going to be? What does it have to have for that to be a true statement?
T.
What do both of them have to have for an and statement to be true?
I don't know.
Okay. Anybody?
Both have to be true, don't they?
They both have to be true. For an and statement, they both have to be true. So Q and R, I'm looking at these 2 columns, and I'm only going to put a true where they're both true. So they're both true here, they're both true here, and that's it. So I can just fill in falses everywhere else. Okay? Now, I'm going to get to this statement. So I've got the Q and R column, which is here, and I have the not P column, which is here. I'm going to look at them both, and I'm going to use the OR. So with an OR statement, when is it false? When is an OR statement false? When they're both false. So I'm looking just at these 2 columns, because that's not P, and there's Q and R. And I'm looking for when they're both false. And that's it. Every other time now, it's true.
Why?
Why is it? Because if it's an OR statement, either one is true, the whole statement's true, because it's OR. Either I'm going to clean my room or watch Netflix. I watch Netflix. That whole statement I just said was true because it was one or the other. If I said either I'm going to clean my room or I'm going to watch Netflix, and then I said I went to the park, that first statement's false because I didn't do either.
Okay, which ones are we looking at to determine the last one?
The not P, which is here, and the Q and R, which is here. And I'm going to do an OR statement for those 2 columns. And so I know they're always true
I'm done. I was just looking at it.
except when they're both false.
My mind switched halfway through it.
Yep. Welcome to logic. This is logic. There's a lot more symbols in logic, but this is all we're going to learn in geometry. If you are really think this is fascinating and kind of cool, you would need to be a lawyer, and you'll take a class on this that's all semester long in college. For now, you just get a little taste of it. But lawyers are very good with logic and reasoning. Okay? So that's how we build a truth table with 3 letters, and then how we can actually create a truth column given kind of a complicated problem by just building it up as we go right. Okay? Questions on any of that? So the things you need to remember from this section are law of detachment, law of syllogism, law of contrapositive, and then how to create truth tables. All right? That is it.